is Thomas Christopher, and my job title is geochemist, petrologist at the observatory here in Montserrat.
I didn't know what to expect. Even though it's erupted a few times historically, we still haven't really seen these volcanoes do enough for a long enough time for us to be certain about what to expect if there's an eruption. I think one of the things that we thought or gave thought to was the magnitude of it if it went explosive, as to how big we thought it would get. And I think in our minds we were thinking somewhere along the lines of 1979. That was not the case. It was a bit bigger than that when the explosion started. So first of all, we weren't even sure if it would go explosive because it was built in a dome. So over time we started to get information, different bits of information as the eruption progressed. And I think one of the most important pieces of information we got in January was the chemistry of the dome, which, when we saw the chemistry was not where it should be for a fresh magma. So we knew that this material that's forming this dome was old 1979 material, and there was something else beneath it pushing it out. The question is, how long would it push for? And if it does push and get to the surface, then what will it do? Or how big will the explosions be? Because you do expect it to explode if it has that much energy. So yeah, it was a bit of playing by ear. As we went along, we were collecting loads of different bits of information. One of the other things I do, even though that's not my primary job at the MVO, is I look at the magma chemistry and the petrology of rocks as well. So I was looking at that information we got back from the UK, from the analysis of the rocks. Then I was collecting liquids from the hot springs, looking for the magmatic signature in them, just looking at the chemistry of the system overall, trying to measure any gases that were there, because initially there was no SO2 flux. SO2 wasn't enough, and there was a simple reason for that. The magma that was built in the dome, that would have lost all of its SO2 since 1979, because it was sitting too shallow to still have any SO2. So initially, the deep magma that was pushing it out wasn't shallow enough to release SO2. So we only started seeing SO2 in any significant quantities just before the explosion started. So the first flux I was able to get properly was on the day before the explosions, because that time it was shallow enough that it could degas SO2. But then by that time it was ready to go explosive. But I think our main job there was just to get the timing of it right and deal with the research after. So we were collecting data and stuff, but we weren't really super focused on the research. The focus was just not to get this wrong, because you've got 20,000 people who needs to be evacuated, and that's not an easy feat, and you needing to give them enough time to do that. So none of us knew when the explosions were going to happen. I think it was either the Monday or the Tuesday the activity started picking up, and then the directive was given, shut down the fieldwork, do not go back up into the bush. So then by the Wednesday and the Thursday, when we started seeing the tremor, we sort of knew exactly what was going to happen. Got the word in from him, says we're going to evacuate at 6. I remember sitting down there in the village, at one of the bars, drinking and just looking at the place, looking at the people, and just thinking, this is going to be very different soon. Whatever it is that's happening here, their lives, this is going to change soon. For how long, I don't know, but I knew their lives were going to change.
My name is Dr. Adam Stinton. I'm a volcanologist, and I have responsibility for dome volume and deposit mapping of the eruptive products from the activity here. Certainly when the explosive phase started, it was quite surprising as to how rapid the explosive phase started and came on. And certainly the number of explosions that occurred were, well, there's quite a lot of them, and it was quite surprising how many there were in such a short period of time. When when activity first started, yeah, it was surprising because there really wasn't any sort of indication that there was going to be any sort of activity at the volcano at the time.
My name is Roderick Stewart, and I'm the volcano seismologist at Montserrat Volcano Observatory. My first thoughts were, gosh, something's happening in St Vincent. It is one of the more active volcanoes in the region, but nothing had happened since 1979, so it was it was interesting, and as a volcanologist, I'm intrigued to know what's going on. And then, well, of course, when the eruptions happened, I was actually there. So my reaction was, oh gosh golly, and trying to get as much data as we could as possible about what was going on. What really surprised us collectively was the rapid dome growth with very little seismicity. Normally we see seismic activity when domes are growing, but in St Vincent we seem to have rapid dome growth with no activity.
My name is Barry Pico William. I think to some extent sad, because having worked in volcanoes all my life, I think I know the danger that can become of it. I know the pressures that could arise on people's lives. So I think that made me sad at first. And my next reaction was to, how can I help to alleviate people's situation? So that's what I think I felt at the time when that happened.
My name is Karen Pascal, Dr. Karen Pascal, and I'm the volcanologist specializing in volcano deformation. The first sign of a dome of a growth was found with the NASA alert system, which was the alert for fires and anomalies, thermal anomalies. So we knew that it was around the crater, but we were unsure if it was an eruption or if it was like just a fire, a bushfire. And so it was like actually really surprising to when the team who's in St Vincent, the St Vincent team from NEMO actually went and they actually saw that a dome was growing, because there had been no sign, clear sign of a dome growing just before. So yeah, that was pretty surprising. And then the explosion, I guess we were kind of expecting it a little bit more, because there had been some increase in seismic activity and in gas as well, not so long before that.
Victoria Miller, and I'm the Hazard and Risk Specialist at MVO. When the seismicity first began to increase, my thoughts were sort of more of a wait and see approach. At that point, we didn't have all the information that we would have liked. The timing was unfortunate because due to COVID, the team weren't able to get out and do some of the necessary repairs. So we were, looking at what we had and observing the data. But when the observation of the surface activity, that's the initial dome breakout on the 27th of December 2020, was confirmed, I guess my first thought was there's going to be a lot of work to do. By the time the first explosions occurred, my thoughts were more simple than that. It was basically just it started, because at that point I wasn't really surprised that the explosive activity had commenced. We've been tracking the volcano for several months and all of the evidence pointed to an increase in activity.
Okay, I'm Rockwell Tapi Sayers. I'm a scientific assistant here at the Montserrat Volcano Observatory. Okay, well, my first impression was, okay, wow, I'm going to get a chance to apply my trade on this volcano like I did here at Montserrat. So I was really looking forward to going there and applying my skills there.